In Bayesian probability theory, if a posterior distribution is in the same probability distribution family as a prior probability distribution, the prior and posterior are then called conjugate distributions, and the prior is called a conjugate prior for the likelihood function. In this video, we shall show the conjugate prior for Bernoulli and binomial distributions are the beta distributions. We will also simulate coin flipping to illustrate how prior distribution evolve after multiple throws. So the Bernoulli distribution is given by this function. If we choose a prior distribution to be the beta distribution given by this function, we shall ignore the constant for the beta distribution. Then the posterior distribution is given by the product of the likelihood function and the prior function. So if we do m throws, the Bernoulli distribution will be given by this product term and multiply by the prior distributions. After some rearrangement, we will get to this, and you can see that the posterior distribution is also a beta distributions given by A, which is the initial parameter for the prior distribution, A plus summation of X, which is the number of hits, and B, which is the initial parameter for the prior, now become B plus M minus summation of X, which is the number of tails. Similarly, for the binomial distribution, we can show that the prior conjugate is also a beta distribution. This table summarizes the prior conjugate for various distributions. For Bernoulli and binomial, we have the beta distribution. For Poisson and exponential, the prior conjugate is gamma. And for normal with unknown mean, the prior conjugate is also normal distribution. Now let's do a simulation of the coin flipping using Python code to illustrate the prior distribution. First, we shall import all the necessary libraries. We will define a bias coin given by the probability P. So if the random number is smaller than P, we return 1, which represents the head, else we return 0, which represents the tail. And then we define a function to plot the prior distribution. So the prior distribution is given by this beta PDF given by the alpha and the beta as a parameter. Then we're going to simulate n times for throwing the coins. Let P be 0.4, and each time we're going to throw 5 times, and we're going to do it for 100 times. So we'll start with the initial prior distribution, which is a uniform distribution. So this is the distribution for the unknown theta for the coin. And after 5 throws, the prior distribution will look like this, which is centered around 0.4. And after another 5 throws, we get a sharper distribution. Another 5 throws, we get a more and more sharper distribution. And it will slowly gravitate to the 0.4. So let's try another bias distribution, 0.9. So we start with a uniform distribution for the theta, and after 5 throws, we get this distribution, and after another 5 throws, we get a sharper and distribution around 0.9. This concludes the video on prior distribution for Bernoulli and binomial distributions. The code can be downloaded below. If you like this video, we welcome your comment, and please like the video, share and subscribe to our channel. Thank you.